This is Earth. Its history lasts 4.3 billion years from planet whose surface is completely covered with molten lava to green forests and endless oceans. However, the history of our planet does not end there. Today we are transported hundreds of 1 million years into the future, in an era when humanity is on the verge of extinction or conquer the stars. Watch the development technology and take a look at the last invention in human history. Then we will see how the new supercontinent Pangaea Ultima will be assembled and sea level will rise to unprecedented values, after which the water will gradually evaporate and only bacteria and archaea will remain, from organisms living underground. 1 million years will pass before our eyes, during which the highest mountains will ascend to heaven and new oceans and continents will lead to permanent changes in ecosystems. Whether humanity can influence the future of our planet and what forces will influence its evolution in the future. Get ready, we are starting. Today our planet is covered with oceans and continents, and there are huge mountain belts on it, deep sea gullers and volcanoes. All this is a consequence. Active tectonic and magmatic life. To figure this out more, try to look into the bowels of the Earth and understand what is its structure and what processes occur there, sadly. To date, there is no device with which you could smoothly penetrate and study the internal structure of the Earth. For now, the deepest mine in the world has a depth of 4 kilometers and the deepest well located on the Kola Peninsula, and has a vertical length of 12 kilometers. For comparison, the thickness of the Earth's crust on the continents varies from 30 to 40 kilometers. Despite this, we know something about the depths of our planet. Our planet has layered structure and several shells. The Earth's crust is the thinnest, and the mantle is the most extensive shell. 70% of the planet. It consists of a solid but less dense than the substance of the core. The deeper the mantle is, the greater its temperature and pressure becomes. It also has a partially melted layer, through which solids move to the core of the Earth. Actually speaking, the core itself is the center of the Earth and is approximately 30% of the total mass. A solid part of the core floats in a liquid layer, creating the magnetic field of our planet. Today, we are most interested in the lithosphere, the whole hard shell of Earth consisting of the Earth's crust and the upper solid part of the mantle. It extends down to the atmosphere of the plastic layer, which allows the plates of the lithosphere to move. The entire Earth's surface consists of lithospheric plates that hold the entire surface of the Earth. The largest is the Pacific, North and South American, Eurasian, African, Antarctic, Australian, as well as many other smaller plates. Our whole earthly relief and location of continents, there is a result of lithospheric plate movement. However, the continents were not always located this way. How we used to see them today, about 200 million years ago, all continents were grouped into a single giant supercontinent, Pangaea. This supercontinent consisted of 2 large parts, northern Laurasia and southern Gondwana, with ocean Tethys in between. All this we know through careful study of tectonic plates. It was a surprise for scientists. When studying the ocean depths, a global system has been discovered. Middle of oceanic ridges, rift gutters, volcanoes and other structures this discovery confirmed. The ocean has an active tectonic life, and it became known that its bottom is much younger than rocks of continents. For example, the oldest breed on the mainland has an age around 1 billion years, while the oldest rock at the bottom of the ocean is only 170 million years old. This opening allowed formulating a new modern theory of plate tectonics. According to this theory, continents gradually move away from the middle ocean ridge, where a new magmatic substance is poured out, forming the bottom of modern oceans. Scientific research has shown that most earthquakes don't happen chaotically, but are concentrated in narrow, elongated zones, often coinciding with abnormal terrain, which indicates the boundaries of the interacting tectonic plates. Complex interactions between plates lead to the formation of volcanoes and mountain systems. For example, as a result of plate movement, Africa is moving to the northeast with almost 2 centimeters speed per year, and India at a rate of 5 centimeters per year. This leads to the formation of the Red Sea, which is expanding at a rate of about meters per century. The Mediterranean Sea will paradoxically disappear in about 50 million years because of the movement of Africa to Europe, leaving behind a new mountain range, equally great like the Himalayas. This way, plate movement and their interaction shape the landscape of our planet, leading to significant geological and seismic events. These studies not only help scientists predict the future of Earth, but also look into our past. That's exactly how, looking at 300 million years ago, at the end of the Paleozoic era, before scientists appeared a single supercontinent called Pangaea. This supercontinent consisted of several large land blocks soldered together by mountain systems stretched along the meridian from the polar latitudes to the equator. Pangaea crossed the globe, creating a single geological and climatic environment which significantly affected the ecosystems of that time. As for the future of the Earth, there are several theories about how the lithospheric plates will move. However, all these theories lead to the formation of another supercontinent. This event is expected in 200 to 250 million years. By then, the ground will be somewhat battered, which is connected with deep processes inside the Earth, namely with the evolution of the structures of the lower mantle. Formation of similar supercontinents in the history of our planet happened at least 5 times and is sure to happen again. The question about whether humanity will survive to the next supercontinent is, of course, controversial. But if it happens, humanity will have to face radical climate change. If land takes positions on the poles of the planet, ice will form and persist much easier, which will lead to extreme global cooling. There is an opinion that any supercontinent formation will lead to radical climate change, since with the advent of one huge array of land, ocean currents will change completely, causing a global redistribution of heat flows. Besides, it is worth considering that subduction of oceanic crust feeds volcanoes. The formation of a supercontinent practically stops this phenomenon. Even though volcanic eruptions are perceived negatively, they help maintain a stable climate on the planet. Remarkably, the hottest and coldest periods in the last 350 million years came during the existence of Pangaea. The Earth in the distant future will not be like this at all, as we know her now. Whatever the next supercontinent is, it will be totally unlike those boundaries which people draw on maps today and then start wars over small plots of land. Nature has proven its power many times before which man is powerless. If in 250 million years, a new supercontinent is forming on Earth, what will happen to humanity? Throughout the history of our planet, life was on the verge of extinction many times. Sometimes global extinction wiped off the face of the Earth up to 90% of living beings, leaving life on the planet on the verge of extinction. And right now, the Earth is facing a threat again. Can one more extinction lead to the complete destruction of life on our planet? Earth was formed 4.3 billion years ago, and albeit by a few billion, life arose at the bottom of the ocean, where unicellular organisms began to thrive around hydrothermal sources. Since the birth of life on Earth, an estimated 5 billion species have evolved, and 99% of them are already extinct. To survive in changing conditions, species evolve and adapt to radical changes in the environment, creating competition for food, water, and space. Species dominant in these conditions are characterized by high adaptability, as per the theory of natural selection by Charles Darwin, while other species struggle to survive and end up disappearing. Animal and plant populations fluctuated throughout geological time. Gradual extinction, as a rule, is a natural process in the evolution of life. However, no adaptations can prepare organisms for global disasters. For the last 500 million years, there were 5 mass extinctions known as the Big Five, each of which almost destroyed life on Earth. To consider an event a mass extinction, it must lead to the extinction of at least half of the species on the planet. Despite natural disasters, life on Earth survived and blossomed throughout billions of years. In the last 2 centuries, the forces of nature have changed. The environment is no longer managed exclusively by natural laws. People, as the most dominant species on Earth, significantly transformed the environment, undermining billions of years of evolution. This leads to a question. Can humans cause the 6th mass extinction, the first since the appearance of man? According to various institutes and research centers, the 6th mass extinction already started in the middle of the 20th century in the period known as the Great Acceleration. The increased pace of human civilization caused significant anthropogenic damage to the land. Rapid progress in technology and growing demand for natural resources dramatically increased the amount of pollutants. One of the most significant factors was the astronomical increase in carbon dioxide emissions since the Industrial Revolution. Humanity produced and discarded carbon dioxide at a rate 100 times higher than any of the last. Lambda Nauge Grok Shodegyup, Deep Search Think Grok 3. This heated the planet by almost 1 degree Celsius, disturbing the delicate balance of the global ecosystem. Rising ocean temperatures, absorbing 90% of excess heat, led to the destruction of rich aquatic ecosystems, such as coral reefs, which could disappear by 2050. Despite this, since the Great Acceleration, people did practically nothing to contain the negative effects of climate change. Because of this, natural wonders such as the Amazon rainforest, one of the most diverse ecosystems in the world, are approaching danger and collapse. Consequences of human activity go far beyond climate and atmosphere. Decades of pollution, deforestation, and excessive consumption caused a deadly cascade of change, comparable with the most devastating disasters in history. The 6th mass extinction already affected 75% of terrestrial and 66% of marine habitats. We destroyed food chains, changed climatic conditions, and violated ocean currents. And now we're losing species at an alarming rate. Approximately 200 species of vertebrates went extinct in the last 100 years, which is about 2 species per year. Importantly, if you compare the current pace of extinction with normal background extinction rates, the same 200 vertebrates would take about 10,000 years to cause the same number of extinctions as a result of natural selection. That means human intervention sped up the pace of extinction more than 100 times, a speed comparable to major paleoecological extinctions. Even low-risk species, including common populations, have serious difficulties. With so many dying and dwindling populations, the planet faces a serious deterioration in global biodiversity. An impending domino effect could further deplete and destroy the world's ecosystems. Modern man thinks himself wise and civilized, but sometimes behaves even more recklessly than the ancient people. Excessive ambition and the pursuit of profit and power have repeatedly led to environmental disasters that threaten the entire planet. The 6th mass extinction is in full swing, and its consequences are becoming increasingly clear. Melting glaciers, destruction of ecosystems, reducing access to fresh water, and growth of toxic waste. People seriously disturb the natural world, and the current landscape foreshadows an even larger extinction. Despite these difficulties, we have the possibility to bring the natural world back to its former glory. Stopping the release of carbon dioxide into the atmosphere can slow the loss of species, reduce destruction and pollution of the environment, and also revive the planet, which once had the greatest biodiversity in history. Carbon dioxide in the atmosphere. Our planet is already burdened, and preferably we not only stop its abnormal emissions, but also remove excess carbon dioxide from the atmosphere. Ending the pointless chase for power, ambition, and profit, we can become the first space civilization in Earth's history. Only the saddest scenarios can stop us. If we avoid them, then we can spawn a vast tree of new life, which which will outlive the Earth itself and settle across the universe. What history taught us is not to underestimate the human race. Lambda nauge grok shada gyop, deep search think grok free.